So hello everyone. Whether I am audible and visual, please let me confirm. Then we will further proceed with our day 3 class. Okay, let me confirm with my device. Guys, please let me know whether I'm audible and visual. If you are there, please say hi in the chat box. Hello everyone. So guys, if you didn't subscribe the channel, still you are not who subscribe the channel, please subscribe it. So we have all done with the chapter motion and force. Now we are in chapter uh, pressure. Okay, it is okay. All set, we are in live. Now we will share the notes of previous class. First we will recall, then we will further move. Okay. So basically what we have covered in previous class, please let me recall, then we will further proceed. Okay, is it visible? My notes is visible to you or not? Okay, it is not visible. Okay. Yes, it is visible now. Okay, what we have covered in previous class. Let me zoom it a little bit. See, in the day 1 class we have seen the pressures and thrust. In simple definition we have defined thrust is the normal force acting on the object, and pressure is in simple word be defined as thrust per unit area of object is known as pressure. We have seen then Pascal law, and we have seen how hydraulic machine work. We have seen how the piston of a larger syringe hold the weight on the piston of smaller syringe up to what weight it can hold. And also we have shown the hydraulic machine, how it work with the pressure principle. Now we are in the topic, so we have all covered those things in the previous class. Now we are in class day 3. Okay, so now we have basically what topic, the construction and working mechanism of hydraulic machine. Okay, let me write. So our topic is for today. So today is our day 3 class. See guys, we are moving very slowly so you can grasp each and every concept. Also we are following concept from the Circulum book. So if you have Circulum book, please take it with you and follow with me. Also, you have a doubt regarding other books or any other sources, you can comment in the chat box, or you can put a messaging uh, WhatsApp community or Telegram community. So we will help you as soon as possible regarding your doubts and problems. Also, you still not subscribe the channel, please subscribe it, and please stay updated with the lecture. If you didn't watch the previous lecture, please go ahead with the playlist and you can watch from there. And guys, please make patience till the course end. So we have all calculated the we have calculated all the proper chapter will be covered in how much days, and how much days we will give for the problem solving and all those things. We have all done calculation of all things, and then we are moving forward. So guys, make patience till the course end, and stay updated with us. Thank you. And we will move further with the topic construction. And what is the topic name? So the topic name is construction and working mechanism of hydraulic machine. So it is the topic name for today, and the date of today's what it is 18. So guys, so you also updated with me, and if you watch the um, coming coming topics by your own with the curriculum books, it will be more helpful. Also, the day which I teach the topic, you at least revise one time, then come to the class, then it will be more beneficial to us. So the topic construction and working mechanism of hydraulic machine is basically tells that the construction of hydraulic machine is at least two cylinder with different cross-sectional area are connected as shown in the figure. A piston is connected to each cylinder in the such a way that liquid inside does not break. Okay. The cross-sectional area of a small piston and the large piston of the hydraulic machine shown in the figure A1 and A2. Let me first draw the figure, then we will further describe it. Okay, we have a just like we have seen, hydraulic machine is used to lift vehicles in larger companies with the application of pressure. So this is the piston here, and here is the piston. So what is pressure, guys, in mathematical formula? Please let me know. Pressure is nothing but force per unit area. Okay, so it is basically telling that the cross-sectional area of a small piston and the large piston of the hydraulic machine shown in the figure is A1 and A2. So the smaller piston is this one, and the cross-sectional area is A1, and the cross-sectional area of larger piston is A2. And the F1 is the outward force produced by the larger piston when the force of F1 is applied on the smaller piston. So let's say this is a small piston and the cross-sectional area is A1 we have, and the cross-sectional area of larger piston we have is A2. Now it is telling that the force of upward coming up uh, through the larger piston is F2. When F1 force be applied on the smaller piston downward in the smaller piston, so it is F1 and here is F2. So what will be the pressures in each of the piston? So this will be in downward direction. So what will be the pressure? Pressure is force per unit area. So force is F1 and area is A1, cross sectional area is A1. So this is the downward it is acting. Now the force is in upward direction with respect to larger piston. So the pressure is force per unit area, that is F2, which is acting upward, and the cross sectional area is A2, which is the cross sectional area of larger piston we have already given. That's all. So now in hydraulic machine, conditions are created for the Pascal law to apply. So what does Pascal law tells? Pascal law tells that when the force is applied in the closed vessel, then the force, the pressure which is equally distributed uniformly at which is normal to the wall of the closed vessel. It is not Pascal law. So let me relate with this hydraulic machine how it is related. So that is when the force applied through the small piston of machine, the pressure generated on the surface is let's say this pressure is P1 we have, and this pressure is P2. So P1 is generated, so it is basically F1 by A1, which is the force we have applied on a smaller piston, and the cross-sectional area of the piston, a smaller piston, is A1, is transmitted perpendicularly and equally in all direction. That's the Pascal law tells. The pressures will be perpendicular and equal in all direction, and the incompressible liquid in the cylinder. So in all direction it will be distributed perpendicularly. According to Pascal law, the pressure generated on the surface of the smaller piston is equal to the pressure generated on the surface of larger piston. So basically what Pascal law basically tells that the pressure is equal. No, okay, let me more elaborate. So in the previous class we have seen see here where we have this one. This is basically Pascal law in mathematical terms. So force per unit area will be always equal to, that is the force will be pressure will be equally transmitted in normal perpendicular direction, that is force per unit area. So we will now conclude that from there by Pascal law the pressure P1 is equal to P2, that is nothing but F1 by A1 is F2 by A2, or we can say P1 is equal to P2. This is now F1 by A1 is what P1. Also we will now conclude that from here we can conclude by interchanging the terms F2 equal to what F1 into A1 by A2 by just sending F2 to A2 will be across multi. Okay, it is wrong. It is A2 by A1 now. So this is our basically equation 1. We are moving to further. So the ratio of area of larger piston to the smaller piston is F1. In the equation, the factor is always more than the 1 because A2 by A1 is bigger than the bigger number that is divisible by a smaller number. So it will basically what? The A2 will be basically larger value na, because it is larger piston. Area will be always greater than the area of a smaller piston. From the observation we can conclude that. So the A2 will be greater than A1, then it will basically greater than 1 or equal to 1. In the critical condition we have 1. So if the cross sectional area of larger piston is twice, let's say it is double of that, basically it will A1 is 2 times of A2. A2 is basically 2 times of A1. We can conclude. So what will it come? A2 by A1. It will basically F1 into 2 because it will become how much? 2A1 by A1. A1 cancel it. This will become 2. So 2 F1 will become when it is doubled. Let me write more clearly here. Okay. So when A1 is, or we can say A2 is 2 times of A1, then basically what we have derived first, let me write here equation first, let me raise it this way. This is to be more clearly looking. This is basically our A2 and this is our equation A1. So now F2 is 2, this F1 into A2 by A1. A2 is what? A1, because we have assumed that A2 is 2 times of A1. So we can write 2 times of A1 and A1 will be cancelled out. Further it will F2 become what? Further F2 will become 2 times of F1 when the A2 is 2 times of A1. So the cross-sectional area of a smaller piston, then the force exerted on a smaller piston of machine become double when it is transferred to the larger piston. So if the cross-sectional area is half of the larger piston, then it will, how much force exert on the larger piston? It will basically 2 times of F1. Or we can say when the cross-sectional area of larger piston here. So this is the cross-sectional area. So when it is 2 times, or we can say in other words, it is half of larger piston. So basically what we are telling, so when the piston cross-sectional area of larger piston, this is larger cross-sectional area piston. So this is basically 2 times of A1. A1 is this one. So when it will become 2 times of A1, so we will put here 2A1 by A1. So what we will get? F2 is 2 times of F1. This one we have. So we have seen how the smaller piston can apply a larger force on a larger piston. So this is used to lift a heavy weight by a small force. Here we will apply a smaller force to lift a heavy object. That's all. So some example of hydraulic machine we can you can see in hydraulic lift. We have already seen that how hydraulic machine or hydraulic lift lift a car in the industry or any other places. So some of the example of hydraulic machines are constructed in various design and shape size depending on their uses. तो हम लोग को हाइड्रोलिक मशीन अपने यूसेस के हिसाब से उसको एक शेप देते हैं, डिजाइन देते हैं, जो हमारा काम करने में आसानी करता है. So some of the example of the presented below. So let me paste the image now so it will better visualize. Okay, we have where it is. See, this is the hydraulic machine we have. According to the uses, we have designed their shape and size. So this is basically what pistons we have. Here we can see the piston. This is the piston, and these are the oil reservoir, and these are the platform for car, how it is lifting. And we have also hydraulic car lift. It will lift up according when we are giving the instruction. So the figure hydraulic lift dentist used by the dentist to adjust the height of chair according to the need and the treatment. The force applied to the small piston connected to the pedal of their chair amplified so that the surface of big piston receive a large force and the patient is lifted upward easily. ये सारा हमारा प्रेशर्स का एप्लीकेशन है. How hydraulic machine lift up the chair or how hydraulic machine lift up the car. That's all. So now we have a question. So basically, the question is telling that in a hydraulic lift, the cross-sectional area of the smaller piston and the larger piston. Let me write the question. Not we will not write the question now. We will directly copy paste the question. Then we will. Okay, where's the question? In the question, it is telling that, so in the hydraulic lift, the cross-sectional area of the smaller piston and larger piston is 0.25 meter square and 5 meter square. Calculate the force required. It is basically doubled the cross-sectional area. So what will be the required to lift the 1200 kg using the lift? So now we have A1, A1 and A2 are given. So A1 is what and A2 is what? Please let me know in the chat, guys. Please, if anyone is there, please let me know in the chat box. Screen strange. Hold the. So what will be the? So it is 0.25 meter square and A2 is 5 meter square. That is all. And A1 is 0.25 meter square and A2 is 5 meter square. So we have given that the force, calculate the force required to lift the car of 1200 kg using lift. Okay, we have force. So it is basically what will be the, this is the mass kg, and weight will become how much? Please let me know. Force is what? Weight, which will use to lift. So minimum force that will be used to lift is its weight, or it's the force we can say. So it will basically how much? 1200 kg into g. G is nothing but what? 9.8 meter per 9.8 meter per second square, acceleration due to the gravity. So it will become how much? 11760 Newton. Now we have already seen from Pascal law, F1 by A1 is equal to F2 by A2. You can just put it on formula, you will get the answer. So what it will, F1 is, we have to find the F1, okay, and the A1 we have is 0.25 and F2 is what? 11760 Newton we have calculated just now, and A2 we have is 5 meters square. The meters square cancel out. This is meters square. So this will become how much? Please let me know in the chat if you calculated. So F1 will become just nothing but 11760 into 0.25 by 5. Is it okay? So from here 20 will be added and 10 will be cancelled out. This will become 2 and this will cancel out to become how much? 588 Newton. That's answer we have. So the force required to lift the car of mass 1200 kg is 588 Newton. That is all about in the activity or example. So now we have hydraulic brake. So what is hydraulic brake? Now we are further moving with the topic hydraulic brake. So what is hydraulic brake? It is also the application of pressure, how pressure is used to apply brake in the vehicle or anything other object, any other object. So we will just do this, and we will cover the hydraulic jack and hydraulic press in the next class. So guys, we are moving slowly. If you still have any problem, please let me know in the chat box. Otherwise, we will move with the topic hydraulic press and hydraulic jack. So please let me add the picture first for better visualization, then we will see the observation. So this is the picture. Let me copy paste in the notebook. Let me expand it. This is the hydraulic brake pressure application. Let me more expand it for better visualization. So see guys, now this is the hydraulic brake. So there is the fluid, and this is the disc pad and build disc, we can say, and this is the step cylinder or block which is on the disc, and fluid filled pipes we are it is fluid filled pipes are passed to the cylinder in block, and this is connected to the other disc, and this pipe is further connected with the master cylinder which have a brake pedal which is connected to the piston, like in the cylinder how it applied to make a brake in the vehicle. It is also used in two-wheeler. It is the four-wheeler hydraulic brake concept, and this is the two-wheeler hydraulic brake concept. So in this figure we can see there is a fluid or reservoir tank which is further connected with the brake pump. This piston will apply in left direction to apply a brake. So this brake is just connected with this piston. When we pull the brake that is in this direction, the brake lever is applied on the brake. This piston will move up in this direction, leftward direction. Are you are you are you getting it, guys? How this piston will move in left direction? When this brake will apply, this piston will move in leftward direction, and this piston up when move leftward, this the liquid in the uh, vessel will apply pressure on the brake house, or it will the pressure will be generated in the vessel uniformly, and which is this pipe is further connected to the brake house, or we can say piston seal is there and brake caliper is there or brake pad is there, and this is the disc, or we can disc, which will apply the brake on the vehicle. That is all the about the hydraulic brake in two-wheeler and four-wheeler. Now it is telling that in the hydraulic brake system the pipe is connected to the master cylinder. Brake cylinder is filled with a special type of brake oil. It is the special type of oil used in the cylinder for the pressure. So the piston are fitted in both cylinder so that they become airtight as shown in the figure. So similarly as shown in the figure second, in two-wheeler vehicle the piston of the master cylinder is connected to the brake lever. This is the brake lever, the black part of that we when we used to ride, we apply this, we observe there it's a brake lever. So the brake lever, what does black or brake lever do? Brake cylinder are located on the wheel of two vehicles. The piston of the brake cylinder is connected to the brake shoes or brake pads. By applying a small force on a small piston, the cylinder, the pressure generated by the pushing fluid inside it transmitted, and the larger forces applied to the large piston connected to the brake cylinder. Due to this, vehicle moving at high speed can stop at instance. That's all we have seen. Just this is the basic concept, how the smaller piston apply force on force on the a smaller piston. How we apply the force on a smaller piston, get uh, move with it will lift up the high, or we can say it will exert a high force on the larger piston. So it is that much large, so it can lift a heavy vehicles, car, or even larger weight, uh, larger weight than the car vehicles. So these are all about the pressure application. Now we can move with the hydraulic jack. So this is the also application of pressure. I think this is the enough for the today class. Hydraulic jack and hydraulic pressure will be covered in the next class. So guys, we are moving slowly so you can grasp the each and every concept very well, and make sure you are revising every day of the class. And if possible, please cover the concept of coming topics, so it will be very beneficial to us. So till now you have not subscribed the channel, please subscribe the channel for further updates, and please like and like also guys, which will motivate enough to make more interesting video. So guys, that's all from my side today. So keep learning and keep exploring. Thank you.